Alright, this is chapter 6, the normal distribution. This is going to be broken up into two parts. First one, we're just going to talk about the normal distribution and the standard normal distribution. And in the second video, we'll just do a couple examples working through them and how they work in practice. So we're actually going to be alluding back to, I think, chapter 2, where we started using z-scores for the first time, and this is where we tie those back in. And I think I mentioned back then that they were used to put things into a standard unit, and that's where we're going to get the name the standard normal distribution. So, first of all, let's start with the normal distribution. It's continuous distribution. It's a function. And it's bell-shaped. It's many things you can list off are normally distributed. Their example here is IQ scores. Think of just an allotment or an observation of data that has no skew to it. It's just all bell-shaped, centered towards the middle, has this type of shape. It's a little bit of just the kind of formalities here. We have same thing, x is a quantity to be measured, that's our continuous random variable, and it belongs to a normally distributed function with mean here and standard deviation here. So that's how you read these and how we'll depict them, but yeah, more right now, let's just kind of talk about what it is. So then we have the standard normal, and you'll notice that it is a type of normal distribution. So it shares the same attributes as a normal distribution, but there's special characteristics. The best way to show this is with this comparison here. This is the same exact curve. We're taking a BMI, which is normally distributed, on the left. We know that the mean is 29, and we know that the standard deviation is 6. Now we take that and convert it into a standard normal. And I think I mentioned that z-scores allow you to compare across different units. So here we use BMI. What if this was the SAT and we had an ACT and we need to compare them and compare their distributions, but we don't have they're different units, so we know they're going to share the same normal distribution. It's just going to be the scales, so we instead put it in a z-score. What is a z-score? A z is the number of standard distributions. So between 29 and 35, that's 6 above it, right? 1 standard deviation, so that would be 1. However, we also normalize this back to 0 so that when we go left, we aren't still in a positive number. And that is what this formula that we discussed converts. So we're going to take z, we're going to take a score minus the mu, that will put it back to its original, think of that as putting it to 0, and divide it over the standard deviations. So like I said, we'll walk through some of this in examples, so I don't want to spend too much about it, but think about it as converting it to a standard unit. That's the key. Once again, I'll go over the empirical rule, and that's just putting it in the, this is a better way to know it, that way it might help you. 68% of the data lies between -1 standard deviation and +1 standard deviation of the mean. 95 lies between 2 and 2, -2 and 2. And almost all the data lies within 3 standard deviations of the mean. It's an important property of the standard normal, and we're going to use it all the time. It's a shorthand. If you know this rule, it'll save you a lot of time, given that you have, anytime you have a whole number standard deviation, a z-score equal to a whole number, then it's going to make your life a lot easier to know those shortcuts. And we'll stop there and pick up with putting it into practice in the next video.